Hello my dear friends, welcome to my channel. Make sure you are a member of my channel. If not, please subscribe and hit the bell icon. So today we are going to see the B.Sc first semester RCUB, that is CBCS syllabus, physics, unit number 3, elasticity. Let's see. It is unit number 1, lecture 1. The concepts we are going to see today is elasticity and plasticity. So what is stress and strain, Hooke's law, and elastic limit, and what is elastic curve. Let's see one by one. What is elasticity and plasticity? The property of the body by virtue of which it tends to regain its original shape or size on the removal of deforming force is called elasticity. The property of the body by virtue of which it does not regain its original shape or size on removal of deforming force is called plasticity. These two are the property of the material. So let's see what is stress and strain. Stress is a quantity that characterizes the strength of the forces causes the deformation on a basis, means base or foundation. It is force per unit area. So next is the deforming force per unit area of the body is called stress. This is the definition. So the SI unit of the stress is the Pascal. 1 Pascal is equal to Newton per square meter. And strain is a quantity which describes the resulting deformation. Strain is the ratio of change in dimension to the original dimension subjected to a set of deforming forces. Strain being ratio has no units. So there are three types of stress and strain respectively. Especially we say that the stress are only two types. So here is tensile stress and strain, the first one, and the second one is bulk stress and strain. The third one is shear stress and strain. Let's see one by one. Tensile stress and strain. You can see there is a box here, that is initial state. It's having initial or original length is L naught. So after applying a force on the faces along outside these two faces, you can see here, so the change in length, that is original length is L naught, the change in length is delta L, right? So make the statements now. Tensile stress at the cross section is defined as the ratio of the force perpendicular to the cross section area A. Tensile stress is equal to force perpendicular divided by A. The tensile strain of the object is equal to the fractional change in length, which is the ratio of the elongation, that is delta L, to the original length, that is L naught. So tensile strain is equal to L minus L naught, that is change in length, we can say that delta L, divided by original length, that is L naught. So here the tensile strain is stretch per unit length. So next one is bulk stress and strain. You can see the force is applied on all the faces, which is perpendicular to all the faces and inward direction, right? So initially you can see the first image, there is no forces, it is initial shape. After the applying forces, it changes its shape, means here you can see it is decreases its volume. So pressure plays the role of stress in a volume deformation. That's why the force per unit area is called the pressure. P is equal to F perpendicular divided by A. So here is bulk stress is equal to delta P and increase in pressure. The fractional change in volume, that is the ratio of the volume change delta V to the original volume, that is V naught, is called as a bulk strain. But volume strain or bulk strain is equal to delta V divided by V naught. And the volume strain is the change in volume per unit volume. So next one is shear stress and strain. You can see the initial state which is having the height h. Now I am applying the force, being the base is fixed and the upper force is tilted, right? That is F11, you can see there in diagram. Shear strain is defined as the ratio of the displacement, that is x, to the transverse dimension h, or shear strain is equal to x by h, that is nothing but tan theta. So the most important concept in this is Hooke's law. So what it says, let's see. Hooke's law states that within the elastic limit, the stress developed is directly proportional to the strain. The constant of proportionality is the elastic modulus or modulus of elasticity. That is stress divided by strain is equal to elastic modulus. That is nothing but Hooke's law. So this is the most important concept in this unit, that is stress strain diagram. You can see in this diagram the direct proportionality between the stress and strain is found to be true only for small values of strain as shown in the figure. This is for small values, it is only true. So the portion OA, you can see in the image, that is O is initial up to A. The curve is a straight line showing that the stress is directly proportional to strain. It means it holds the or obey the Hooke's law here. Up to the point A. This point is called the elastic limit. The point A is called elastic limit. Beyond point A, the curve is not a straight line. You can see here, the curve is not a straight line. In this region, AB, the strain increases more rapidly than the stress. The strain is increasing here compared to the stress. Stress is not changing much, right? And the behavior of a material is partly elastic and partly plastic. In both ways, it is behaving. If the object is unloaded at B, it does not come back to its original condition along the path AO, but it takes the dotted path, that is BC. You can see here, that is BC. The object is said to have acquired permanent set. This is called the permanent set. There is just permanent changes is occurred in that set, right? And OC is called the residual strain. I hope you understood this one. So beyond the point B, the length of the wire starts increasing without any increase in stress. Thus wire being to flow after point B and it continues up to the D. The point B at which the wire begins to flow is called yield point. Beyond the point F, the graph indicates that the length of the wire increases even if wire is unloaded. The wire breaks ultimately at point E, called the breaking point of the wire. The portion of the graph between D and E is called the plastic region. So the permanent changes is occurs, that's why D and E is called the plastic region. There is nothing elastic properties present. So next is three types of elasticity, that is modulus. There are three types of strain, that's why there are three types of elasticities. The first one is linear elasticity called Young's modulus corresponding to linear strain, and the second one is elasticity of volume or bulk modulus corresponding to volume strain, and the third one is elasticity of shape or shear modulus or modulus of rigidity corresponding to shear strain. Let's see one by one. Volume modulus, what it is? When the deforming force is applied to the body only along a particular direction, the change per unit length in the That direction is called longitudinal or linear or elongation strain. The next point is the force applied per unit area of cross section is called longitudinal or linear stress. The ratio of longitudinal stress to linear strain within the elastic limit is called Young's modulus, and it is denoted by capital Y. In mathematically we can say that Y is equal to longitudinal stress divided by linear strain, or simply we can say linear stress to linear strain. The next point is consider a wire of length L having area of cross section A fixed at one end and loaded at the other end. Suppose that a normal force F is applied to the free end of the wire and its length increases by small l. So longitudinal stress is equal to F by A, force per unit area, and the linear strain is change in length to the original length. So next, there are three types of stress and strain respectively. Especially we say that the stress are only two types. So here is tensile stress and strain, the first one, and the second one is bulk stress and strain. The third one is shear stress and strain. Let's see one by one. That is bulk modulus. It is defined as the ratio of the normal stress to the volume strain. It is denoted by capital K. The bulk modulus is also known as the coefficient of cubical elasticity. And mathematically, we can write capital K is equal to normal stress divided by volume strain. So we will try this one. Consider a cube of volume V and surface area small a. Suppose that a force F, which is acting normally over the whole surface of the cube, produces a decrease in its volume by small v. Then normal stress is equal to F by A, force per unit area, and volume strain is equal to change in volume to the original volume, that is capital V. Therefore, K is equal to similarly normal stress by volume strain. Therefore, F by A whole divided by V by V. So, just the rearrangement, that is capital F into capital V divided by small a into small v. Now the pressure is defined as force per unit area, that is P is equal to F by A. Here you can see I just replace the F by A here. You can see there is a negative sign. If the volume increases on increasing the stress, the bulk modulus is given by K is equal to PV by V. Here the negative sign is why? Because the volume is decreases. That's why we have taken the negative. If it is increases, then we take the positive sign. The unit of bulk modulus are Pascal or Newton per meter square in SI. Compressibility is nothing but the reciprocal of the bulk modulus of the material is called compressibility, that is 1 divided by K. I hope you understood this one. So we'll the remaining concepts in the next video. Please subscribe for more videos. Thank you.